Hey Kipsters, today we're going to be working with Module 4, Lesson 22. Take a couple seconds to make sure your paper looks like mine. Our objectives for today are that you're going to be able to show that constant rate can be described by a linear equation in two variables, y and x, where slope is going to help us determine the constant rate of that problem. And you're also going to be able to compare two different proportional relationships represented by graphs, equations, and tables and determine which has a greater rate of change. So we'll be going back to the work that we've done with constant rates. Remember, constant rate was equal to a given distance over a specific time. And some will be in graphs, some will be in tables, and some will be in equations, and we'll compare those ratios to determine which is greater. Go ahead and recall your definition of constant rate. So remember, you're going to have our distance, which is our y variable, divided by our time, which is our x variable. And constant rate and slope are used interchangeably. In a few points in this lesson, I'll start to switch over and say average speed. No, I'm talking about the same thing. Let's start with our first example. So example 1 says a faucet leaks at 7 gallons per hour. Remember, we use cubes to circle important numbers. I'm going to go ahead and circle 7 gallons. I'm going to bring the units with it per hour. I don't see a number there, but I know per hour means 1 hour, so I'm going to insert a 1 there. Suppose y gallons leaks in x hours. I'll circle this. Looks familiar to me. Some gallons and some hours. Express this as a linear equation in two variables. So now I'm underlining my question. I want to box out any operations. I don't see any operations, but I'm going to recall the title of this lesson. The title of this lesson is called Constant Rates. So I'm going to assume that I will be using this formula distance over time. If you recall from previous lessons, whenever we want to write a linear equation in two variables, we always create a proportion. So if we say the leak began at 6 a.m., and the total number of gallons leaked over the new time interval from 6 is x hours, then we know the average rate of the leak is y over x. So we're going to start over the left side of our equation with y over x. We know that the faucet leaks at a constant rate, and we should have been given that constant rate. That constant rate is 7 gallons per hour. Cool. Then we use cross multiplication to multiply and express our problem in a different form. So we're going to get 1 times y and 7 times x. All right, our goal when we're writing this two variable equation is to isolate the y. You could do that by dividing both sides by 1, and you can just see that you can drop off that 1. And our two variable equation is that y is equal to 7x. Remember that slope in this equation is the same as the constant rate of the leaking faucet. So faucet A leaks at a rate of 7, which we knew, 7 gallons per hour. Another faucet leaks at a constant rate. And the table below shows the number of gallons Y that leak in X hours for 4 selected hours. What is the constant rate of the second faucet? Well, there are a few different ways that we can calculate constant rate or slope when we've been given points or ordered pairs. The way that we're going to work with, or the way that I'm going to model right now, is very similar to what we've just done at the top. So we know that constant rate is equal to distance over time. So I'm going to look at any row in my table, and I'm going to select a given distance and a given time. I'm just going to start with the first row. So I'm going to select my given distance of 13 over my given time of 2. All right. Then I ask myself, how many times can 13 be divided by 2? Well, I know that there are at least 6 2's in 13, which leaves me with 1 left over, and you put it back over your denominator of 2. So this constant rate is equal to 6.5. All right, question C. Which faucet leaks more? Justify using math. Well, faucet A leaks at a constant rate of 7, and faucet B leaks at a constant rate of 6.5. Think back to lesson 15 where we were talking about the steepness of graphs. Which graph was steepest? The graph with the largest ratio or the graph with the smallest ratio? The graph with the largest ratio is steepest. So we would say that faucet A has a greater leak than faucet B because the ratio is larger. Constant rate or the ratio. 7 gallons per hour is a bigger leak. More than 6.5. All right, so that's our first example problem. You could have also used 2 given points. So you could have labeled 1 point P and 1 point R. Remember, X and Y are ordered pairs, and I could have done 26 minus 13 over 4 minus 2. Okay, you would end up with the same answer, 13 over 2, and getting down to a constant rate of C. So in this first example, we compared an equation and a table. Let's look at exercise number 1. All right, in exercise number 1, you can see that I've already used cubes to annotate my problem. You can pick up like me if needed, but it says express this situation as a linear equation in 2 variables. Go ahead and set up your proportion. All right, so when we express this as a linear equation into variables, you'll see that you get y over x equal to 2 divided by 1. You're going to cross multiply. You're going to get 1y equal to 2x. All right, and then you can divide both sides by 1, but you'll isolate the y and you get that the equation is y equals 2x. What's the constant rate of this problem? Okay, because we know we're going to be using that the constant rate of this problem is going to be 2. All right, so now we've been asked to sketch the graph of the linear equation. Well, there are some steps to sketching a graph of a linear equation. They're going to be in the top right of your page right now. You won't see them on mine. So I want to identify that known point by identifying my y-intercept. So my y-intercept is where the line crosses the y-axis. Remember, x must be 0 for that to happen. So I've rewritten the equation. I'm going to substitute in 0 for x. When I compute and get that math, I get that y is equal to 0. So I know my first known point I need to plot is 0, 0. Next step is I'm going to use the slope to move up the graph to the next point, up the line to the next point. Well, my slope tells me I need to move up 2 and to the right 1. So I'm going to do that. I'm going to move up 2 and to the right 1. So I have plotted my first couple of points. I'm going to plot my first point at 0, 0. All right, and then I want to move up 2. Notice I'm only moving up 1 point and to the right 1 because the y intervals move by 2. So every time I move up 1, I'm really moving 2 and to the right 1. Then I get to the next point on the graph, up 2 to the right 1. The next point on the graph, up 2 to the right 1. I should be able to use my ruler, my straight edge. I'm using a piece of paper, the edge of it. Line up those points, and I should produce a straight line. Good question C. Question C says, using the graph or the equation, determine the total area he's going to paint after 8 minutes, 1.5 hours, and 2 hours. So I've done some annotation. So we need to determine the total area that he's painting in these different time intervals. On your paper, you're going to see a table. All right, so go ahead and convert some hours into minutes. Once you've done that, please use those times to substitute into the equation. You'll notice that 1.5 hours is not on our graph. Our graph tops out at minutes. So let's convert 1.5 hours to minutes. I know so instead of X for time, I'm going to substitute 90 minutes. And I'm going to do that math, and I get that Y equals 180. So in 1.5 hours, he would paint 180 square feet. Was 2 hours. So if in 1.5 hours it was 90 minutes, okay, I can add another half an hour to that. The figure below represents Nathan's constant rate of walking. So let's examine Nathan's graph. What is Nathan's constant rate? All right, well, let's find any distance over any time. Scanning the x-axis. Let's do 1 hour. And it takes him 4 miles. So he can do 4 miles in 1 hour. When I do distance divided by time, I get that his constant rate is 4 miles per hour. You've probably seen this abbreviation, miles per hour, MPH. All right. Part A, Nicole just finished walking a 5-mile walkathon. It took her 1.4 hours, 1 4/10 of an hour. Assume she walks at a constant rate. Let Y represent the distance Nicole walks in X hours. Describe Nicole's walking at a constant rate as a linear equation in 2 variables. So remember, we want to use this key information to express a linear equation in 2 variables. Track back to the first example if you need. Now I want to cross multiply and I want to solve this in terms of Y. All right, B, who walks at a greater speed? So you have Nathan. Let's just take the first 3 significant digits after the decimal. So I'll say that this is really equal to 571 thousandths. Who has the greater speed? Explain. Yeah, you should say that Nathan has the greater speed because his constant rate is larger. All right, so in example number 2, we just compared constant rate in 2 different forms. Nathan's constant rate was given as a graph, and Nicole's constant rate was given as a word problem where we created the equation. Know that when you're working with a graph, find any distance over any time and calculate constant rate. And when you're dealing with an equation, you should be looking for the number attached to X, the coefficient attached to X, when the equation is in terms of Y. All right, let's look at number 3. Susan can type 4 pages of text in 10 minutes. Assuming she types at a constant rate, write the linear equation that can represent this situation. To reduce this fraction, it simplifies to the fraction Y equals 2/5 X. All right, now let's look at this table. Table below represents the number of pages Anne can type in few selected minutes. Assume she types at a constant rate. So the question is, who types faster? Well, before we can determine who types faster, what do we need to know about Anne? We need to know Anne's constant rate. I can figure out Anne's constant rate a few different ways. Select which way you plan to figure out Anne's constant rate. All right. So I'm going to choose any distance over 3 minutes. Who is faster, aka which ratio is great? Would you rather have 2/5 of something or 2/3 of something? I'd rather have 2/3 of something. So Ann types faster because 2/3 is greater than 2/5. Phil can build 3 birdhouses in 5 days. Assuming he builds birdhouses at a constant rate, write the linear equation that represents the situation. So go ahead and follow the same steps as above and write the linear equation that represents Phil's situation. It should be the linear equation you have. Let's go ahead and turn the page. This figure represents Carl's constant rate of the building the same kinds of birdhouses. Who builds the birdhouses faster? Explain. Remember, we can use this graph to determine Carl's constant rate. Remember, when we're using the graph, we want to identify 2 integer coordinates to find our distance and our time. So we could find the slope of this graph by identifying 2 integer points. Remember, you always want the x variable first and then the y. And remember, our formula for calculating slope from any 2 points on the line is to take the y values and subtract them and divide that by the x values and to subtract them. All right. When you stack your ordered pairs, it's easy to operate this way. So I'm saying that slope is equal to 3 minus 6 over 4 minus 8. Continuing to work vertically, 3 minus 6 in my numerator is going to give me negative 3. 4 minus 8 in my numerator is going to give me negative 4. Remember, when 2 negatives are being divided, you're ending up with a positive. That makes sense because this is a left to right inclining line, so I know that slope will be positive. So this tells me to get from P to R, I should move up 1, 2, 3, and to the right 1, 2, 3, 4. I verify, I know that my slope is 3/4. But I'm going back to the question. The question asks who types faster, Carl or Phil? Well, remember, Phil's constant rate is 3/5. Ask yourself the question, would you rather have 3 out of 4 birdhouses built or 3 out of 5 birdhouses built? 3/4 is bigger. Therefore, Carl builds birdhouses faster. Let's go to question number 5. Explain your strategy for comparing proportional relationships. Be sure to use a complete sentence.